Hello! We still have 15 seconds on the timer, but I don't care. So I talked to some people much smarter than me. And by some people I mean I talked to my discrete mathematics professor, who has a PhD in grid theory. And he came up with some novel solutions to try to help me with my problem. None of them work. We did the math. That's not how that works. But it did lead me to thinking about soft body simulations, and that, like spring deformation and dampening, which is actually how we're going to solve this problem. And I have this really nice article on mesh deformation in Unity. Everything's nice. It's by Can't Like Coding. Can't Like Coding is fantastic, for those who don't know. I don't know why. The grid
Alex
breaks.
or something 1234 has renewed his membership to Parliament for 3 months. Hello Mr. Owlman. Today is my last day as member because I need money Shadio12LUL Shadio12LUL.
Well, thank you very much for the resubscription. And yeah, man. I've appreciated your support. If you can't do it anymore, that's totally fine. I appreciate you guys sticking around. I enjoy hanging out. So, we're gonna try to solve the mesh deformation problem. And I think that I'm gonna read this article, and then I'm pretty sure I should be able to solve it. Because I did a bunch of, like, research, like, before streaming yesterday. One of the things is the problem that we were running into. Let me get dark mode paint. There we go. So one of the problems that we were running into when me and my math professor were trying to figure this out was when you have a set of vertices like this, if you move one of them too far, like we have this line that cuts them in half, right? Because we have two triangles. If we move this vertice too far, like let's say that we moved it right here, then we have overlapping triangles, which breaks the mesh. And if we move things too far, then that becomes a huge problem. And one of the cases that he was talking about is, let's say that we only move this vertice, but we don't end up moving these ones. And then eventually we will get over this line, and that'll break the mesh. The way that we can fix that is through damping, and making sure that all of the vertices are, like, properly spaced, which I didn't know how to do. But nerdy music?
According to my calculations, you know, the grid deformation is actually quite a difficult problem.
Is that how I need to talk when I'm explaining this? Alright. Being a nerd is fun. Damn you. Everyone's a nerd about something. You're a nerd about Undertale. And all of its derivatives. And now it sounds like hell of a boss. Which is awesome. You found your thing and you like it. Yeah, I need to adjust the camera. Okay. We're like mostly good. That's okay. Whoop. Okay. I had to adjust my camera because I had to take a calculus test, which you use something called RP Now, which is basically just spyware on your computer, and every single time I use it, I will complain. Every damn time. I hate it. Okay, let's read this article. So this is an introduction to mesh deformation. We'll turn a mesh into a bouncy mass and poke at it. Basically, this is what he does in the end. Wait. Yeah. To where it deforms and then it goes back. We just wanted to deform it. We don't want it to go back, but it's probably not a bad idea to know how that works. You like help a boss when sex jokes are occurring. Fair enough. Yours is called Responds Lockdown? I have no idea what you're talking about. Makes you... Oh, wait, that's what your RP now is called? Makes you restart your computer? Dude, I hate that. Why do colleges do that, man? That drives me bonkers. I think the worst part is that you are stuck there. Like, you can't go to the bathroom because they're like, you're cheating. You're cheating. I'm like, ma'am, this test takes 3 hours to complete. I do not have an iron bladder. Goodness. Okay.
Alex or something 1234
Alphys,
Redeem
okay.
suggest a song. Alphys.
Alfie's theme. You bastard. Put on nerd music. You son of a bitch. I know what you're doing. This tutorial follows a cube sphere. It is a continuation of the same kind of mesh manipulation. We'll use the cube sphere as our test model. It is suitable for Unity 5.01 and up. Scene setup. Okay, we start the scene. Cube sphere at center. You can either make it from scratch, continue... Okay, removing everything is no longer needed. Okay. So this is just, it has even vertices. It is a regular cube sphere. I'm not doing the nerdy voice, man. I can't do it. I can't do it for that long. Alright, create a new mesh deformer script to take care of the deformation. Just as the cube component needs a... Just as the cube sphere component, it needs a mesh filter to work. Okay? So the cube sphere, this is the grid size, and then he creates another script for the mesh deformer. Note that we only require a mesh filter. We don't care how it gets a mesh. Right now we're using our procedural cube sphere, but could be any mesh preparation. To perform any deformation, we need access to the mesh. Once we have the mesh, we can extract it. We can extract the original vertex positions. We also have to keep track of the displaced vertices during the deformation. Acquire the mesh and its vertices in the start method, and copy the original vertices to the displaced vertices. Okay. So he gets the mesh filter. Or he gets the mesh. From the mesh filter, he creates a array, which is the original vertices. Okay, so this is just an array of the original vertices and then an array of the displaced vertices. And then... Okay, he just sets all of the displaced vertices equal to the original vertices. Okay. So he literally just copies all of the vertices. We know to do that, that's easy. Okay, we're using the start. So we're using starts, so procedural meshes can be generated in awake, which is always invoked first. This approach relies on other components taking care of their stuff in awake, so it's no guarantee. You could also adjust the script execution order to enforce it. Actually, how does this work? Oh, damn, nice. The music is killing you. It's perfect music for this, come on. Alright. It's the ultimate way. Is there like a... Wait, nerd video game music? No. It's just the angry video game nerd. Shucks. Now this is a banger, okay? You suggested this. Reap what you sow. I actually do like this song, though.
fits my personality so well.
Okay. Create a new mesh deformer. We already did that. Okay. Just the script execution order. I did not know that this was a thing. Script execution, add scripts to the custom order, drag them in to reorder. Scripts in the custom order can execute before or after the default time and are executed from top to bottom. All of their scripts execute at the default time and are ordered in the order they are loaded. So you can, like, make sure that it actually works in that order. That's cool. Didn't know that was a thing. Okay. Okay, vertex velocities. Vertices move as the mesh is deformed, so we have to store the velocity of each vertex. Okay. I don't think we're gonna have to do this, but it's probably not a super bad idea. Because he's doing this in real time. We just simply don't need to do that.
Alex or something 1234 just followed.
Why does it trigger every time? I don't understand you. I don't understand you, Alex. I need to make a clause in my... I need to actually program my stream setup to specifically not... Whenever you follow, specifically just you. Every damn time, man. It's very funny. I don't know why you could do that. It's so silly. Okay. Mesh deformer input. We need some way to control how the mesh is deformed. We will use user input for that. You don't need to give your monthly bit donation. Goodness gracious. You said you need money. Save your money. Okay. We need some way to control how the mesh is deformed. We'll use the user input for that, so it'll be interactive. Whenever the user touches our object, we'll apply a force to that point. The mesh deformer component takes care...
Alex or
oh my
something
goodness.
1234 through 100 shinies. Cheer 100. Oops, my finger slipped. I had these lying around. I didn't pay for it.
Okay, okay. Well, thank you very much for the 100 bits, man. I appreciate it, Alex. But yeah, don't go throwing money at me if you don't have it, man. Okay. We need some way to control the vertices. The mesh deformer component takes care of the actual deformation, but doesn't care about the input method. We should create a separate component to take care of the user input, give it configurable input force. Okay. Makes most sense to attach this component to the camera as it represents the user's point of view. Okay. We shouldn't attach it to the deforming mesh object because there could be
Alex
multiple
or
of those in the
something
scene.
1234 redeemed forced exercise. 5.25 Aztec push-ups and
0.25.
5.25 one-hand push-ups.
We're an integer-only household here. I'm gonna be rounding those. 5.25. I actually need to set up IV cam real quick. Wait. Give me one moment. And then we'll have the exercise cam. I was a bad streamer and I forgot to completely set it up. Oh wait. Oops. I need to cancel that. Give me one moment. Nope, that's not gonna work. Ah! Okay. Oh, come on. And to close this, you can see, wait, you can't see. I have like literally 16 apps open to keep this stream running. I need to figure out a way to do this better. What did I just open? I think it's IV cam. Come on. Open! Okay, it should prompt it for USB debugging. There we go. Okay. Give it a second. Any moment. There we go. Wow, that was horrible. Okay. 5 Aztec push-ups, 5 one-hand. I can't do a one-hand push-up. I actually can't. How about I do 5 normal push-ups and 5 Aztec push-ups? I am incapable of doing a one-handed push-up. And yes, I need to fold my laundry. Okay. One. Oh man. Oops. 2. 3. 4. 5. Yeah, no, I can't do that. One. 2. 3. 4. 5. Okay. You can't see the cam? Oh no. I'll redo them. Damn it, man. Okay. I'm already sweating. 1, 2, 3, 4, 5. Okay, those 5 normal push-ups. 5 more Aztec. Okay. Oh man. Aztec push-ups are hard. 2. 3. Oh. 4. 5. Okay. Oh no. Horrible mistakes have been made. Oh man. Oh, strong. Yeah. Okay. Whew. Thanks for the exercise break. I appreciate it. Whew. Okay. So he sets the mesh deformer input script on the camera. Alright, sure. Detecting input. We'll handle user input whenever we... The default mouse button is held down, so whenever there's a click or drag, as long as the user keeps pressing. I'm pretty sure that I have a cooldown on that. I really hope I have a cooldown on that. If I don't, then I need a cooldown, okay? I'm gonna have to, like, take 5 minutes before I do that. Read this article. No, I gave you guys the power, okay? You're not being an asshole using the tools I gave you. Okay. And figure out user input. Pointing, we can use a raycast from the camera to the scene. We'll grab the main camera from the scene and use it to convert to the cursor position to the ray. No, no! Dude, Aztec push-ups are so hard. My shoulders are not happy right now. Because the force that you need to, like, just propel yourself up like that feels so much more than a normal push-up. Oh, dude. Okay. We use the physics engine to cache the ray, store the engine, or store the information about what it hit. The ray collided with something, we can retrieve the mesh deformer component from the object that was hit. Also, I'm keeping this song on, okay? Fits this perfectly. You're right. You were right. Yeah, I don't need physics.raycast, but sure, it gets the mesh deformer. Okay. Because I'm already getting the position, so I know where the position is, it's fine. Maple candied bacon. That sounds... Honestly, I hate bacon. I don't think I would like that. Yeah, sure, let me just hand you some through the internet. Did you get it? I shoved it into my camera. That worked, right? I just plopped on your desk through the screen. Yeah, no problem. Anytime. Okay. We have something that has a mesh deformer component on it, then we can form that something. So go ahead and add deforming force to the contact point. Okay. Add deforming force. Right now it's just is a debugger, okay? Of course, it assumes the mesh deformer has an add deforming force method, so let's add this method. It's not deforming anything yet, so let's just draw a debug line from the main camera to the point to visualize the ray. Okay. Fair enough. Force offset. The experience, this is the real point, or this is the real thing that I need to understand. Easy. It always works every time. Why did you think I was lying to you? Of course it worked. Oh man. Okay. Force offset. The experience we're trying to invoke is the mesh being poked and dented by the user. This requires the vertices near the contact point are pushed to the surface, or pushed into the surface. However, the deforming force doesn't have an inherent direction. It will be applied in all directions equally. This will cause the vertices on the flat surface to be pushed apart, not pushed inwards. We can add a direction by pulling the force away from the surface. A slight offset already guarantees that vertices are pushed off to the surface, into the surface. The normal at the contact point can be used as an offset direction. Okay. Sure. Is this doing what we want? Yes, kind of. Yes, this is doing what we want. Okay. So, the force offset, so that just pushes it back. And it uses the normals. We don't need this point at all. This literally does not matter to us. But sure. Basic deformation. Time to do some real displacement. Mesh deformer dot add deforming force is a loop through all currently displaced vertices, and apply the deforming force at each vertex individually. Okay. So it does literally everything? Is this like getting a distance? No. It's just deforming the entire mesh. Okay. So, add deforming force has the point and the force. Sure. Int I, so this is looping through all of the displaced vertices. Okay, so it's everything in the displaced vertices. Which is all of the vertices, so yes. Every single one of them, sure. Add force to vertex. What is add force to vertex? Okay, this is a new method that he's defining. Okay, so he defines the method add force to vertex, which takes in the vertex index, the point where the force is originating, and the force. Okay, so we need to convert force to velocity. The mesh is deformed because a force is applied to each of its vertices. As the vertices are pushed, they acquire velocity. Over time, the vertices all change their position. If all vertices would experience the exact same forces, the entire object would move without changing shape, but they don't. Think of a big explosion. If you were ground zero, you're dead. If you're nearby, you get knocked down. If you're too far away, or if you're far away, no problem. Force diminishes with distance. Combined with differences in orientation, this attunement is responsible. This attenuation, sorry. I have no idea what that word means. This attenuation. What does this mean? The reduction of the force, effect, or value of something. Okay. This is a physics term. That's why I don't know it. Everyone point and laugh at the physics nerds. Okay. This attenuation? I don't know how to say it. This attenuation is responsible for the object's deformation. So we need to know both the direction and the distance of the deforming force per vertex. Both can be derived from a vector that points from the force point to the vertex position. Okay. The attenuated force can now be found using the inverse square law. This is something that I found a lot in the research, is when you're trying to displace a grid or displace a mesh, anything like that, like when you're talking about gravity forces or explosive forces, where something's either being like or gravity, like where everything is coming towards a certain point and deforming around it, or like a repulsive force where everything's trying to move away from that point, which is what we're trying to do. Doing the inverse square law will stop vertices from overlapping. It seems. I think that it will. The math should check out. Just divide the original force by the distance squared. Actually, I divide by +1 the distance squared. This guarantees the force is full strength and the distance is 0. Otherwise, the force would be at full strength at distance of 1, and it shoots toward infinitely. Shoots toward infinitely to get closer to the point. Okay. What is... We're just gonna open up Desmos. So this is 1 divided by x squared, and this is 1 divided by x squared plus 1. Oh, yeah, that's a problem. So that way it is actually 1. Okay. We're never gonna have a negative, because this is a distance. So it always has a positive magnitude. Okay. And then we can just say, like, at a certain point, it's almost 0. So we can just basically say it's 0, probably. Although, actually, maybe not. That would cause problems, so let's just not. Yeah, no, this is fine. What about 2? That'd be half the force. That would be double. Okay. So by adding something to it, we actually... Oh, that's because... That way it will be defined at every value. Because even if this is 0, unless this is -1, at -1 it should be... no, wait, because it's squared. So this will always be defined. Okay. Set to like 0, 1, yeah, so that just basically guarantees that the function is defined at every point. Because otherwise, if it's just 1 divided by x squared, then at 0, it's technically undefined, so it's a hypotenuse. If you don't know what that means, don't worry about it. It really doesn't matter. Okay. This guarantees the force is at full strength when the distance is 0. Otherwise, the force would be at full strength at a distance of 1, and it shoots towards infinity closer you get to the point. So yeah, there's the 1 plus x squared. So the attenuation force equals force divided by 1f, which is 1, plus the point to vertex, that square magnitude. Okay. Okay, so yeah, because he's squaring the distance, and that's the magnitude. This point to vertex, this is the distance. This is a vector of the distance. So he's just squaring that. Okay. Now that we have our force, we can convert it to a velocity delta. Actually, the force is converted into an acceleration via a equals fma, or f divided by m, which is just force divided by mass. Which, if you've taken any calculus class, you should know that F equals ma, which is the force, it's Newton's second law, it's the net force is equal to the mass times acceleration. So, solving for acceleration, configuring the function around, doing a little bit of algebra, you can solve for that really easy. And the change in velocity is found by the velocity delta. So this is, yeah, change in velocity is the change in velocity equals the change in acceleration times the time. To keep things simple, we'll ignore the mass as if it were 1 for each vertex, so we'll end up with the velocity delta equals the force times, or the force delta times the difference in time. No, it's just the force times the difference in time, sorry. So yeah, it's the attenuation force that we just calculated times time.delta time. At this point we have a velocity delta, but not yet a direction. We find that by normalizing the vector that we started with, we can add the result, or we can add the result to the vertex velocity. Okay, so this is, again, he created an array of vertex velocities. Updating vertex just... Okay. It's just a for loop. Goes through all of the different displaced vertices, and then updates them. Are the vertices updated all the time? Yes, each update, all the vertices are displaced. Assigning to the mesh, the normals are recalculated, even no force has been applied. If the user is not deforming the mesh, then it can be considered a waste of time, so only use this when the point is to constantly deform the mesh. So yeah, this way, this may be all we need, actually, from this. It's just the inverse square law. But I'm gonna keep reading. Staying in shape. Vertices now start moving as soon as we apply some force to them. They don't stop. To keep vertices in the original shape of the object, keep moving and the original shape of the object will be lost. Let's now make the object bounce back to its original shape. Real objects are solid and compressed, and are compressed and stretched while being formed, or while being deformed. They resist this deformation and can also return to their original shape once left undisturbed. Since we don't have a real volume, just a collection of vertices that describes a surface. We cannot perform realistic physics simulation with this, but it's not a problem. All we really need is something that looks believable. Good old smoke and mirrors. Yeah, so this is really, really springy to where it'll just keep going back and forth. You just got a 100-pound propane canister and then realize that you need an adapter for it? That's rough, buddy. Is this for your smithing? For your propane forge. Awesome. How are you healing up? Are you doing good? Okay. So right now we're just... Okay, good. We're reading through this article because it solves the problem we need. I think it solves the problem. And we're going to try to implement and actually see if it does. We're talking about the inverse square law, which is apparently how you stop the vertices from crossing over, which is a big problem. Because it will get infinitely close, but it will never actually go over. Which is exactly what we want. Mostly. We do want it to kind of, like, bounce back a little bit, so we're looking at the damping portion too. Okay. So, springs. We're keeping track of both the original and deformed position of the vertex. Imagine we attach springs between them, or between the two versions of each vertex. Whenever the deformed vertex is moved away from the original, the spring will pull it back. The further away the deformed vertex is, the stronger the pull of the spring becomes. We can directly use the displacement vector as a velocity adjustment, multiplied by a configurable spring force. This is simple and looks pretty good. We do this each time the vertices are updated. Okay. So, he sets the velocity. And this is for each vertex. He sets the velocity based on the vertex velocities. Then he sets the displacement, which is just the difference between the displaced vertice and the original position of the vertice. Which is a displaced position where it is right now, and the original position of the original shape. And then this displacement is used with the spring force to change the velocity, dampen it a little bit. Or not exactly dampen it, but bring it back. So vertex velocity equals velocity, displaced vertices plus equals velocity. And then he does some damping for this, which causes it to actually go back properly and not do this and like spring back and forth infinitely. Okay. Vertices now resist deformation and jump back to their original position, but they overshoot and keep bouncing without end. This happens because the springs keep pulling on the vertex while the vertex corrects itself, increasing its speed. It only slows down after it's moved back too far. We can prevent this eternal oscillation by constantly slowing down the vertices. This dampening effect is a substitute for resistances, drag, inertia, and so on. It's a simple factor that decreases the velocity over time. Okay, so yeah, it's just a damping factor. Dealing with transformations. Our mesh deformation is now fully functional, except when we transform the object, all our calculations are performed in local space. Go ahead and move or rotate our here. See that the deformation will be applied incorrectly. We have to compensate for the object's transformation. We do this by converting the deformation force's position from world space to local space. So yeah, he just does that here. So that way it still works in local space. Welcome, Darth. So, right now, I'm still solving the same problem I've been solving for like the past week or two. We're trying to figure out how to deform a mesh without breaking everything. And I found this really good article by Cat-Like Coding, and I think that this solves our problem. Mostly because the inverse square law and damping. It's like 90% of it, so we're going to try to implement that. And see how it works. Okay, I'm going back. There we go. We're out of the nerd shit. Okay. So I'm just going to drag this article. Actually, no, I'll reference it on screen. It'll be okay. So we're just gonna copy everything that we're doing here. You've been working on the Lumberjack game the past week. You got on the other side of the coin of teamwork. Not even close to what we had. What does that mean? Like, to where everything is working perfectly, or everything is going... It's nad? Bad? Oh. I'm sorry to hear that, man. Yeah, finding teammates that really want to work together and, like, do everything and really put their passion into the project is really difficult. I was genuinely really surprised at how, like, to be fair, we fumbled a lot in the Pirate Software Game Jam, like, really hard. But I feel like there's a lot of passion that went into trying to do that. And when something was bad, we just talked to each other. It was fantastic. It was one of the first times that I have, like, worked with people and just like, wait, this is what working with competent, like, people who know what they're doing, that are mature. I was like, this is insane. This is amazing. Every time I work with the team, I am now going to expect that. You've changed my standards. Which is a good thing. Okay, that is a good thing. What did I just download? I don't want the Unity package. I don't know. Whatever. I don't need your package. That's why I'm doing it myself. "20-minute RimWorld load time? What settings did you input, brother?" You're asking the other dev, do you think that we can do A, B, and C in 2 weeks? He's like, yes, I'll deliver it before the weekend. What do you do? Anything but. And I needed to tell him to read the game design document more than once. Yeah. I mean... what 124 mods does? Jeez, man. Yeah. I've worked with a couple of people. So the game that I'm actually currently working on, I tried to make before. But a couple of things. First of all, I was very inexperienced at making games and also interacting with teammates. So, didn't go very well. And alternatively, the people I was working with did not... that team did not work. And that was, like, the main thing. I got really demotivated because I was doing... like, I put in a few hundred hours into that project, and everyone else combined put in, like, 20. And I was really mad about that. I was like, dude, how? Why? Because I just kept designing. It was supposed to be, like, a multi-year project, which... bad idea. We overscoped, but yeah, it's okay. I'm scoping down and now making the project. With more experience. Okay, so we need to get the force, which I think we already have a deformation force. Yeah. This is going to be Hammer Force. And then... Okay, Vertex Velocities. Sure. And then with the damping, isn't there another thing we need? I think. Yeah, best of luck with the project, man. Finding the right people to work with, it's hard. It's really hard. But you're a fantastic developer. You'll find someone. I trust. I think. I hope. Okay, it's the distance. We're getting the force divided by the distance. Okay. I might also... Actually, that's fine. I don't need this anymore. I just need the hammer force. You're giving another week or two. You have other projects to do. You got Fmod working? Nice. Okay, I need to just completely gut this entirely. And yeah, this just didn't work. This hurts me. Goodbye. Ugh. Okay, I'm gonna create... We're gonna have our current vertices, and then we're gonna have another vector 3. And this is the last vertices. And every time we do this, we're going to set the last vertices. But we won't deal with that right now. Right now we have the distance. Reading vector 2 distance. Okay, awesome. And we need to do the force. We're gonna have a float. This is called the what did he call this? It was, yeah, the attenuated force. Attenuated force. And it was the force, hammer force, divided by 1 plus the distance dot... Oh wait, this needs to be... What? This needs to be a vector now. Okay, this is gonna be a little bit jank, but should be fine. Because we can do this, and then we can just convert it to a vector 2. We can cast it, rather. Vector 2 test. Why are you not happy with that? Okay. Okay, we're just casting it to a vector 2, so that's fine. So this is the distance vector. Distance vector dot square magnitude. And that's what the attenuated force is going to equal. Fmod is the... It deals with, like, audio management, right? I've seen a little bit of Fmod usage, but I'm not super sure how it works. It seems like one of those really useful plugins, though. Is it first party, like Cinema Machine? Okay, so we're doing this. What did he call this? Point the vertex? Okay, yeah, we'll call that. point to vertex. And it was... Wait. The vertice minus the point. Not the other way around. Okay. It's a dynamic audio SDK, basically. I'll send you a few good slides. Okay, awesome. Thank you. Alright, so... we have the inverse square law, we have the attenuated force. We just need to apply that, basically. We'll also do the vertex velocities. I don't think I'm going to need this. Like, at all. But I'm just going to follow the tutorial, and then I'm going to rip it apart. Okay. You take a picture of your monitor? Okay, Cerebrum effect. Okay. Has Cerebrum effect on it. Random frequency. Okay. So it interacts with events, and then... okay. Well, the auto manager, so any script in the project can be easily triggered. Okay. You're watching it while you work out. Nice. Unity project, it... wait, so it's like a completely separate thing than the Unity project? Play events, stop events, set parameters. Interesting. That's real weird. It's completely different? It's so weird, man. Okay. Alright, so... yeah, with this vertice velocities... okay. We need another one. Private vector 3. Yeah, vertex, velocity. And we're going to here set vertex velocities to number of verts. So vertex velocities equals new vector 3 number of verts. Okay, perfect. World just crashed after initializing for 20 minutes. How a bummer, man. That's brutal. Holy crap. Fmod creates an asset with a JSON for all events you set up. In the example, you're doing an Fmod event in the Fmod, setting a loop for rain, and the action cycles between 3 thunder sounds randomly, or pseudo-randomly. When Unity... okay, in Unity you just call an Fmod event, and it's going to trigger. Okay, interesting. How does that work with, like, exporting your game? Does it work in WebGL and stuff? Does it get shoved into your project? Or do they have to install Fmod? I presume that it has to get shoved into your project somewhere. That'd be really weird if it didn't. Like, really weird. Okay. It's just a Unity asset? Okay. Then yeah, it probably does. I doubt that they would have to install something. That'd be really weird. And would really limit the usefulness of that. Okay. Yeah. Ugh. Ugh. It's a plugin, it's part of the build. It's DLLs. Okay. Okay, now vertex velocities equals... Yes. Point to vertex, not normalized. Point to vertex, not normalized, times attenuated force. Okay. And then we have to update the vertices. Oh my goodness. Evan. Eek. Bye. There we go. Okay. Ah! Alright, so then we update the vertex. Velocity equals that, because we're doing it in the for loop. I'm just going to do that here. So, that is a vector 2. Right? No. It's a vector 3, technically, but, like, really doesn't need to be. Vector 2, velocity, equals vertex velocity is I. Okay, and now vertices I plus equals velocity. Okay. Sure, and then it'll just set the last one to 0, I think. It should. It should. I don't know why you can't add a vector 2 and a vector 3 together. I feel like that's like... Come on. Is that really that hard? Ugh. Okay. And just updates it. Okay, awesome. And then this is springing it back. So we can create another serialized field. Private float. Spring force. It's a big overhead, I guess, each time you check if you got past the vector 2 or vector 4. I guess, or vector 2 or vector 3, sure, but like, this is valid. So like this is a vector 2 getting set to a vector 3. It's just, it's not even that much overhead. You can literally, they could just have two functions. One just, if it's vector 2, one if it's vector 3. Like, these exist. It's just the same function, basically, but it has different arguments. I feel like this would be so easy. I don't know. Maybe I'm a fool, okay? I don't know what I'm doing. But, like, from where I'm sitting, come on, man. Yeah. So we're doing the displacement. Every time we need to set the last vertices equal to vertices I. Also, whenever I do this, I need to... What? Okay, there we go. I need to have a... I need the last vertices, and that's going to... Not equal vertices, it's going to equal new vector 2. Or vector 3, rather. Number of verts. So this just initializes everything. I'm gonna move these out, and this is going to be for mesh the... or for, yeah, mesh deformation. I'm just gonna comment that a little bit. Once the game takes 20 minutes to initialize, crashes, you relaunch the game, it takes 5 minutes to get to the main menu. Okay. Yeah, that's a bummer. RimWorld does not seem particularly optimized. One game that is incredibly optimized is Factorio. I don't know how the hell that game runs. There's so many things happening all the time. It's like actually insane. Like, the fact that Factorio even functions is insane to me. And the fact that it functions well with giant factories of everything happening at once is absolutely bonkers. Okay, now I need a displacement. So we're gonna get a displacement, which is the current vertices position. Okay, wait, no, I need to change the vertice position, and then I need to get a displacement. And then I need to change the vertice position again. I think. Okay, wait. Okay, wait, I'm gonna create a vector 3, and this is gonna be current vert. And then we're going to do... We're gonna get this displacement, which was just the difference between the current vert and the original vertice. Okay. And that's a vector 3, that's displacement. Vector 3. Displacement. Okay. This is... No, there's no reason to do this. The displacement is always just the velocity. The velocity is the displacement. So I need to have velocity minus equal itself. times the spring force. I don't actually think there's any point in ever doing this. I don't even think I need this.
Followed.
Hey, well time. Thank you very much for the follow. Victoria's a masterpiece of optimization while RimWorld runs here on one... It runs on one core? That's a lot of things to be doing for not optimizing for multi-threading. This seems a little bit bonkers. That is what that means, right? That's what multi-threading is, I think. Maybe. I don't know what I'm talking about. Forgot to follow last time. Well, you're here now! I appreciate it. Thank you very much for the follow. We're trying to still figure out the same problem. I did end up solving the mesh generation issue. We got the mesh generating. But now I'm trying to deform the mesh. And I found this really good article by Cat-Like Coding on how to do exactly what I need, basically. So I'm stealing all of his code. And then I'm going to probably have to change it a lot. But the main thing is the inverse square law, which I already knew about, I just didn't think to use it. I found that a bunch in the research that the inverse square law was very good for making sure that things don't go infinitely. Like, they can't reach the end ever. Because it just, like, it fall off so fast. Okay, so... Single transformations, I don't need to do that. It should solve the overlap stuff, yeah. It should. Should. And now we're adding spring forces and damping real quick, and then I don't even think I need spring forces. In fact, I am very sure it won't do anything, but I'm adding it for posterity's sake, I suppose. Okay. Our vertices now resist deformation and jumps back to their original position. I'm actually... Okay. I'm editing his code in real time, which I probably shouldn't be doing. I should just add it to the project, and then it not do what I need to do, and then I can edit it to do what I need to do. Okay, our vertices now resist deformation and jump back to the original position. But they overshoot and keep bouncing without end. This happens because the spring keeps pulling. Well, one moment, actually. Whoop. Yeah, my hope is that this does solve the problem. The overlap problem. Okay, so our vertices now resist that information, jump back to the original position, but they overshoot, keep bouncing without end. This happens because the vertex itself. Okay, so he just... It's... Yeah. And then velocity times equals... We need to add a damping factor. One F minus damping factor. This should work. I'm pretty sure. I can do some optimizations. I don't need that. I do need this. Okay. Hopefully this works. We'll see though. The biggest optimization is just to delete all the code. True! Okay, now this does nothing. Somehow. Oh, it's because I set everything to 0. Or rather, I just forgot to set everything. Let's go with like 1 or like 4 for the hammer force. Okay. Oops. This is in the opposite direction. There we go. There. Everything is moving towards. Okay. Let's set that to like 0.1. Let's set that to like really low. Okay. Well, everything is... It's not overlapping, though. It's just crunching. It's not overlapping, though. Let's set the damping to like 0.5. Okay, no, this is just going in the wrong direction. Yes, this is just entirely going in the wrong direction. So no, the other way was right. It's just the spring force was so strong. I think I can just get rid of the spring force, like entirely. I don't think I need that. I'm also going to do one small change. I'm just going to set this of a range between 0 and 1. Oh my goodness gracious, it works. Alright, let's set this to like 0.1. This needs to be way smaller. This totally works. Now, if you just keep hitting one point, then it gets like... The vertices get all messed up. But they will no longer overlap. And that was the biggest problem at the time. Now we just need to deal with this really heavy... I am trying to force an overlap. It is not possible. Wait. Okay, it is possible. It just overlapped. No!
Screw underscore it underscore.
Man.
Let's underscore do underscore. It has renewed his membership to Parliament for 3 months. Memes.
Thank you very much for the renewed subscription, man. I appreciate it. Memes. Okay. Wait. Now the spring force should force these away more. I think with the spring force, it is completely impossible to overlap. We'll see though, wait. Nope, there we go, there's an overlap. Oh! It's really close to impossible. But still technically possible. It's a huge problem. That's if I turn the damping factor like way up. Okay, then things just move less, so let's put the hammer force up a bit. Yeah, the problem is... It's not that the vertices will ever get past each other, but they can cross that center line. And that's where things start breaking. Like, even if we just had a 1x1... Yeah, you can see... The vertices will never get too close to each other, but they will break like that. I would do that if I knew how. Honestly, the main problem is I'm not exactly sure how to do that. Like, this works fine on, like, for instance, the two corner vertices, like, here and there, this will never be a problem. It literally cannot be a problem, because the line is here. Like, if we look at the mesh, the line is here. It's going like this, so if we do it this way, then this is fine, because the triangles are always okay. So what I might need to do is if it crosses like this line, then I need to change it to where if it crosses this line, then now these lines need to be connected, not those. That'd be really hard though. It would just be old position of any move vector plus velocity never crosses all other edge vectors, but I don't know how to calculate the edge vectors. Like, first part. Like, I understand that it's a problem, but we have this edge, right? I don't know how to calculate where this point is. I guess it could just be between these two. Like, if it gets too close to this one. Because this vertice, if it goes over half of the distance of this, then it immediately breaks everything. So we could either regenerate the mesh to where whenever someone does that, then we take all the vertices and then we just change this triangle. We change that quad. Alternatively, we could just have every mesh and not be a quad, but instead be... No, that wouldn't even change anything. What's really the problem here? Let me turn this mesh up a little bit. Like, let's go like 4, 4 again. It's just when the vertices of triangles cross. So, like when one triangle, when a vertice that is not shared by that triangle, or by both triangles, crosses the middle line between them, it immediately breaks. So, like, if this one crosses this line, or if it crosses this line, if it can't cross this line because it's connected to this line. Maybe I could have every vertice be like this, or every quad be like this, to where instead of it being 2 triangles, it's actually 4 triangles, and then every single time we move one of these vertices, we calculate the center point between all of them, and then we move that there. Are there any weird configurations of these vertices that would be a problem with? This might be the solution. Wait. Because even if, like... Even if we have something like this, then a center point here would connect all of them. Like, as long as these don't overlap. problem is so complicated. At least it feels that way. I'm gonna solve it. It's gonna be so easy. Couldn't the middle vertex not or still cross the edges? Yes. But what I'm proposing is that we make it to where it literally never can. To where we don't ever actually move that vertice. But instead, we just move the other vertices, and then we recalculate the position of this vertice based on that. So we'd update each quad, basically. Trying to think, are there any combination of 4 vertices that would break this? Okay, then we just place it here. Okay. What if this vertice crossed with that? Like, what if this vertice right here actually went over here? Because then we would have... Basically, it would be a back face. That would be a problem. That would be a problem that this solution doesn't solve. Yeah, they could become twisted. Hmm... Okay. How does this even solve that problem? Let's just set this to where it, like, literally just follows the tutorial exactly, and it's a real-time movement. So we're going to set... Yeah, last vertices equal to vertices for everything when we generate the mesh. And then I need to refollow this real quick. Yeah, I think it does if it's simulated over time, but I'm trying to figure out how to do that in one instance. Like a single frame, how do we make sure that it doesn't? Like, this isn't a problem. Yeah, so the displacement is... Are we ever calculating the displacement? No, we're not. Vector 3. Displacement equals... Is it last vertice? No, it's the current vertices I minus the last vertices, which is, this is just technically the start vertices right now. Okay. And then we need to do displacement. We just brute force checking the vertex movement, or the vertex movement doesn't cross over any adjacent edges. That's like that's a lot of work though. I feel like there has to be a more elegant solution that would take less time than brute forcing it. Mostly because I just don't know how to do that. Okay, wait. So here's this. We still have this crossing problem. Okay. I might try that. We'll see, though. I'm gonna try this. I'm just gonna try implementing exactly what he has. Which means I need to add time.delta time a lot. Okay. Oh, yeah. So this is just whenever we do it, we need to do the attunement force, but whenever we click, we need to do the attunement force, but otherwise we don't. Okay. Yeah, so we're just gonna do velocity. Oh wait, I need set the velocity over here. And we need to get the vertex velocities high. And then okay. And that's multiplied by that. That should be right. Yes, that's correct. That's correct. Okay, we're there. Okay. That's the problem. Okay. Rename. No. Okay. Oops. This just needs to be a float. How is this a problem? Is it because he makes velocity vector 3? Oh. Okay, that's kind of cursed. That's okay. We're gonna have a private void update vertices. I'm just gonna steal this code. Yoink! Mine now. So these are just vertices. We're just gonna do vertices. Change that. We need a for loop here. Int I this yoink. This is just vertices divided by or minus last vertices. And to grab all this, put it in here. Okay. We're good there. I don't need this anymore. And then we just need to update vertices every frame. Update vertices. Okay. We're gonna add the damping force. We don't have to deal with that. What did I read? Wait, what did I name this? Is it just damp force? Oh, it's damping factor. Okay. Okay. Let's see how this works. I need to make sure that this is correct. It should be. I hope. We're gonna set the damping factor way lower and everything higher. Okay, why is this happening in slow motion? Damping factor way down. 40. 60. Okay. Okay, so it does eventually cross. What the hell is happening with the spring factor? Okay. Yeah, it just moves. It's so weird, okay. Huh. I still don't know how this isn't causing problems in his mesh. I don't think this ever springs back. I set this to like 600. We're getting a little bit wacky. Wow, okay. Like 200. Then we'll set the spring force to like 70. This is really interesting. It's not what I need, though. Am I setting this at any other point? The last vertices. I'm only doing that... Yeah, here. Okay. Oops. Wait, I made a mistake. There we go, now it should bounce back. I think? No, it just doesn't. It just doesn't bounce back. Why? Why don't you bounce back? Like, actually, what the hell? Hey, Eternal. It's been a while. We're trying to deform a mesh. And it is deforming, just not in the way we need it to. Okay. Why isn't it bouncing back? What did I mess up here? We tried making meshes in Blender. It looks super complex though. Yeah, we're doing this through code. It's It is super complex. Very confused. Okay, wait. Yeah, this is only happening in... It also happens in fixed update whenever I change it. But, like... It's only when I change it. Like, if I go in here and I activate the mesh, or activate the scene, and then I start changing things. If I do this, then everything gets reset. Which is good. We want everything to be reset. This is, like, weirdly satisfying. My copy and paste game is lacking. Sorry, my mistake. This is creating interesting results. It's just kind of not what we need. I don't know what is happening. Because eventually it should... Like, the spring force and the displacement will eventually lead to it bouncing back. Like, it should go in the opposite direction, right? One thing, and I don't think this would even change it, he has his mesh in the opposite way. He's doing his mesh like this way.
It underscore let's underscore do underscore it redeemed
Whoa.
to say according to all known laws of aviation, there is no way a bee should be able to fly. Its wings are too small to get its fat little body off the ground. The bee, of course, flies anyway because bees don't care what humans think is impossible. Yellow, black, yellow, black, yellow, black, yellow, black.
Thank you for that. You know, if a bee can fly, I can do this. Alright? If a bee can fly, I can figure out this problem. Somehow. Some way. What if I just remove damping entirely? What code am I using? This is from... Cat-like coding. Cat-like coding makes it a bunch of Unity, and now he's doing Godot tutorials. Okay, so if I remove damping, it doesn't go back, it just breaks. Awesome. Welp. Okay, wait, what if I just do the exact same thing? Okay, what if I do it here instead? Because why? It should be going back. I feel like there's something wrong with the way that I'm setting it, to where it might be like getting a pointer or something. Okay, now something's breaking. What do you mean? Wait, but I'm doing it literally right here. Oh, that's not good. Yeah, I need to set last vertices equal to a new vector 3 number of verts. Man. Wait, that was the problem. Okay. Now we're cooking with portals. Interesting. Let me add damping again. Okay, so we have something. Things are happening. And it's damping down, and then eventually it stops. I am not making a portal. Okay, let's go Hammer Force like 400. Well, this is a neat soft body simulation. I don't know if this exactly does what I need to do. Okay, wait, if I turn the Hammer Force up enough, can I cause it to, like, it does. It will break the mesh. Okay. If I get it at just the right time, then I can, like, set it to launch. Whee! Okay, this is so silly. This does not do what I need. But it is really fun. It's just, yeah, this isn't right. This isn't what I need. Whee! Booba minigame? No. No. Very fun, though. I like it. So. What if we only do this once? And then we get rid of the time that delta time. What happens then? It'll break. I know it'll break, but like... Ooh... Yeah...
Screw underscore it underscore.
This is
Let's
so wrong.
underscore do underscore it
Whee!
and deemed to say Isaac and his mother lived alone in a small house on a hill. Isaac kept to himself, drawing pictures and playing with his toys as his mom watched Christian broadcasts on the television. Life was simple and they were both happy. That was, until the day Isaac's mom heard a voice from above.
What? Okay, well, this is a neat simulation. Truly not very useful for my purposes, though. So, I'm trying to deform the mesh in the way that... I'm trying to deform the mesh whenever you click, all the vertices around it move out of the way. And I'm trying to do that in a way that leads to the mesh not breaking, which it breaks when... So let's say that we have a quad here, right? And there's two triangles on it. When the vertice down here crosses this line, then it becomes something like this, which it does not work. It just breaks. It's very annoying, and I'm trying to figure out... I might just do it manually, like Time was saying. Calculating line segment overlaps is pretty trivial. How? How do you do that? Line overlap. Hootie. Okay, this is a solved problem. I want to try one more thing with this. I want to try if I increase the mesh density a lot. So, instead of IJ, it's like that divided by 4. And then we're going to do divided by 4, divided by this times 4, I think. Yes. And now we're going to have really, really dense meshes. First of all, really small meshes. And we're going to increase this to like 64 by 64. And we're going to have a real big mesh. And it moves. We have a ton of vertices. That is a crazy amount of vertices. Okay, let's go like 30. Let's go like 12 by 12, maybe. So it's actually on screen still. Okay, wait. What about a 24 by 24? Alright, 32 by 32. Awesome. Now I have really big squares. And then if I increase the hammer force a lot to like 50, if we actually look at this mesh, I don't need to see these vertices. It's a lot of vertices. How is it that many? What? How the hell is that even possible? Okay, wait. I'm actually not going to multiply this by 2 or by 4. We're just going to do this. Because 32 by 32 is how big the texture is. Okay, wait. So we can still visualize it. Now I want this to be like 500 and like 200. Then we're going to turn the damping down a bit. It's just a jello-y mass. Turn the damping like really high, then it's a lot better. Okay, the spring force is too high, it looks silly. Let's turn the hammer force a lot more and turn the spring force down. Force way up. Spring force a little bit down. Let's go to like 20 on the spring force. This is interesting. Like, this is interesting. It kind of doesn't help us, but I like it. Wee. Okay. I'm gonna create another new scene. Actually, I'm just gonna create maybe a new object. Because I want to completely change the way that we're... I need to test this. I need to test the line overlaps. Because I'm not exactly sure how to do this. And this is a 2D matrix. This is... Oh... This is a... What the hell are you? This is a matrix of matrices. I don't really know how matrices work, so... Oh, the thing you linked is a really simple explanation? Awesome. Okay. Okay. There's a nice approach to this problem that uses vector cross products to find the two-dimensional vector cross product. V times W, which would be VXWY minus VYWX. Suppose the two line segments run from P to P plus R and from Q to Q plus S. Then any point on the first line is representable as P plus TR for scalar parameter T. Any point on the second line is QUS, parameter scalar U. The two lines intersect if we can find T and U such that P plus TR equals Q plus US. Cross both sides with S, getting... Okay. S. Is this the cross product S? Oh yeah, it's this cross product. Okay. So, cross both sides with S. Since S cross product S equals 0, this means that the scalar T R cross product S equals Q minus P cross product S. Therefore, solving for that, it is T equals Q minus P cross product S divided by R cross product S. The same way we can solve for U. Okay. So then you solve for U. Literally the exact same thing, you just swap R and S. Makes sense. Okay. Trying to think, how would I implement this? Because I need to see if a point has crossed it. I don't know if this helps me, because when a point has crossed it, like thinking of this example again, to where we have the line in the center, and then we have it like this, to where this is the back of the face, because it's already crossed over. What lines would I check? I guess if I check the line like this? Because when it's here, I guess I always need to make sure that these cross. So the line from this to this vector always needs to cross with this one to this vector. Otherwise we have problems. And if these don't cross, then we have a problem. Vertex start position to move position, then check that against any neighboring edges. That would also work. Okay, so we need to figure out the cross product. How do you... I always forget to do cross product, mostly because I never actually properly learned it, but my linear algebra knowledge is really shaky. Okay, how do they do it here? This is in C. This is just an implementation of what this person said, I think. We'll figure it out. Okay. Vector 2 dot cross? Are you kidding me? Wait. Why is there no vector 2 dot cross? No, there's a vector 3 dot cross. Vector 2 dot cross. Why? Why does this not exist? Ugh. Okay. Why? What's even the point, man? Welcome back, Alex. Okay. Okay, so if R cross product S, or R cross S, equals 0, and the P minus Q cross R equals 0, then the two lines are collinear. Okay. What does collinear mean? Collinear. Does that just mean that they're parallel? The points AD and C are collinear. Okay. AB and C are not collinear. I see. Okay. Yeah, paralleling the same path. Perfect. Okay. So, reduce the computation steps. Do the following. Okay. And there are two lines are collinear, which that means that they're crossing. Yes, because they have a point in the center. So in this case, express the endpoints of the second segment, P and Q plus S, in terms of the equation of the first slide segment, P plus TR. Okay. So I need to check that these, so I need to calculate both of these, T0 and T1, and then I need to check if they're equal to each other. If the interval between T0 and T1 intersects, then the line segments are collinear and overlapping. Otherwise, they're collinear and disjoint? Okay. Note that if... What does that mean? Line can be represented a pair of points determining a given pair of closed line segment are disjunct. They're... Okay, so if you kept going with the line, then eventually it would be. Okay, sure. If R cross S equals 0 and Q minus P cross R does not equal 0, then the two lines are parallel and non-intersecting. Okay. If R cross X does not equal 0, and T is greater than 0, is between 0 and 1, and U is between 0 and 1, the two line segments meet at the point P plus TR equals Q plus US. Okay, so either one of these points. Otherwise, the two line segments are not parallel, or are not parallel but do not intersect. Okay. Um... I'm gonna make another script just for this. Line, cross, check, checker. Then I'm just going to create line, cross, checker, and we're just gonna drag that onto there. So I have just a fresh script to try to figure out what the hell is happening. Okay. Public vector 2. First point. Okay, wait. Line A, point 1. Line A, point 2. Line B, point 1. Line B, point 2. I'm going to have a header here. It's going to be line B, and then this is going to be line A. Can we get a line render, or 2 line renders, rather? I'm just gonna disable this for right now. And that. Okay, it already has one. That's fine. Here's what we're gonna do. We're just gonna create 2 empties. It's gonna be line renderer 1, line renderer 2, header, activate, and we're just going to have a public bool, check lines equals false. I mean, it's already gonna equal false. And then we're just going to, in the update, if check lines, then check lines equals false, and then we're going to update everything. We're gonna have 2 private line renderers. Line render A and line render B. I'm just gonna call this line A and line B. And we're going to create a line render lines. We're going to have 2, and that's going to equal get components. Or wait, find objects by type. We're going to find all the line renders in the scene. What? Can I not make a... Oh, okay. Sure. Don't even... What is your problem? To declare a managed array, the rank specifier must precede the variable definer? What? Don't specify the size? Okay. There we go. What is your problem? No overlap method? Find objects by type? It takes 0 argument? What are you talking about? Okay. Find objects by type. Include. I hate you so much right now, Unity. I hope that you understand how incredibly angry I am. None! Okay. Fantastic. Thanks. And now we're going to do line A equals line 0, line B equals lines 1. Goodness gracious. Okay, actually, we'll just set them ourselves. No, we won't. I don't care enough. Okay, so... Brother. Okay, let's start figuring out these variables. So we have P and Q. Vector 2P. I could just code the or I could just copy the code below. Yes. No, wait, this is 4 points. That's what I have. Okay. Yeah, so this is gonna be...
Screw underscore it underscore let's underscore do underscore it redeemed to say Isaac and his mother lived alone in a small house on a hill.
Goodness
Isaac kept
gracious.
to himself, drawing pictures and playing with his toys as his mom watched Christian
Okay, this
broadcasts
is line
on the television.
8.2.
Life was simple and they were both happy.
This is line
That was, until the
8.1.
day Isaac's mom heard a voice from above. Your son has become corrupted by sin. He needs to be saved. I will do my best to save him, my lord, Isaac's mother replied, rushing into Isaac's room, removing all that was evil from his life. Again, the V.
This should be right. No. This is all should be line 1. No, wait, this should be point 2, and then this is line B. So I just need to change this to B. B. B.
Screw underscore it underscore let's underscore do underscore it redeemed to say again, the voice of
Brother.
Isaac's soul is still corrupt. He needs to be cut off from all that is evil in this world and confess his sins. I will follow your instructions,
Oh,
Lord.
brother.
Isaac's mother replied, as she locked Isaac in his room away from the evils of the world. One last time, Isaac's mom heard the voice of God calling to her. You, they done as they asked, but I still question your devotion to me. To prove your faith, I will ask one more thing of you.
Okay. So now this is... You know, I think here's what I'm actually going to do. I might just set...
Screw underscore it underscore let's
Brother.
underscore do underscore it redeem to say yes, Lord. Anything. Isaac, S. Mother begged. To prove your love and devotion, I require a sacrifice. Your son, Isaac, will be this sacrifice. Go into his room and end his life, as an offering to me to prove you love me above all else. Yes, Lord, she replied, grabbing a butcher's knife from the kitchen. Isaac, watching through a crack in his door, trembled in fear. Scrambling around his room to find a hiding place, he noticed a trapdoor to the basement, hidden under his rug.
Oh, is there more? Goodness gracious. How long have you been saving up points for that? That was 1,500 points. Okay. Don't hit me with the smile. About 3 streams. That's amazing. That's awesome. Okay. You're a legend for that one. I can't believe you did that. What the hell? Oh, man. Okay. So again, this is easier Y, which is this one. Uh-huh. And then this is P2Y, which is this one. So we're just doing the same thing. No, we're subtracting it now. Who names their variables like this? What the hell, man? This is insane. Why did it... Why? Who does this? Okay. Filthy C programmers. Okay, print. Collision at. He said that the collision occurs at P plus TR. So that is the first line, I think. Which is, yeah, the first point. Probably. I have no idea at this point. What the hell's R again? Okay. Plus T times line A minus... Cool. This should be right. We'll see. And then I want to change the line renders to show this. And line A. How do you actually do line renders again? Dot position count? Dot... Okay. Dot set positions. Okay, we're gonna set them to line A, 0.1, and line A, 0.2. What is your point? What is your problem? This has to be a vector 3? Why? Brother. Okay. Vector 3. I love it. Love it so much. Vector 3. Oh wait, this needs to be... Okay. New. Or vector... Yes, vector 3. Line A. Positions. I'm just gonna do this, actually. Could I just set them to line A 0.1 and line A point... Are you complaining because you can't implicit... What the hell is your problem? Is it because this returns void? No, that was the problem. Okay. Now we're gonna do the exact same thing for line B. To be honest, this is a little bit cursed, but I'm okay with that. Alright. There are 2 positions on each of these. Perfect. Line checker. Let's go with, like, -2, 2? We'll just go with, like, yeah, negative... Let's go with 0. Or -2... No, 0... -2, and then 0, 2. And we're gonna do -2, 2 check lines. What? Oh, this is doing string concatenation. Whoopsies. Okay, let's just... Vector 2... Collision point. There we go. Flush collision point. Alright. I forgot to set these with a material, so that looks super bad. Materials. Okay, default line, thank you. Just want this to be a solid color, possibly? Could you just do that for me? Nope, okay, awesome. Yeah, let's do like a red here. And then we're going to do, sure, white works. And now I need to go in. Again, we're going to do negative, let's do -3. 3. -3. 3. And we check it. There's a collision at 0, 0. And now if I do -3, 2. Oops. So that is right. That's good. I need to lower the width on these, like, way, way down. Let's go with, like, 0.1. 0.1. Okay. Or wait, no. What am I doing? Why am I here? Where are we? Okay. And this is going to be -4 and 4. We're going to check that. There is a collision at 0, 0. Now we're going to add something like that. It looks roughly correct. I'm actually going to set a game object to that. We're gonna have a space with like 25, and then we're going to have a header. It's going to be assignment, and then we're actually going to get rid of this, and we're just going to assign everything. Public transform. Collision object. Okay, this seems to just work. I think. I hope. Possibly I cope. No collision, fair enough. -4, 4, and then we're gonna go -4, 4. Okay. I'm not actually changing the click cursor. Oops. We're going to set the collision object equal to the collision point. Collision point. Vector 3. Okay. Oh, that position. Oops. Do I need to make vector 3? No, okay. We're just gonna set this to like new vector 3 -1000 1000 0. So we're setting it off to La La Land. Okay. Where is my cross checker? -3, 3. -3, 3. Okay, awesome. No collision. Fantastic. This totally works. Which is bonkers. Thank you very much for suggesting this whale time. You've Saved my ass? This is super neat. Okay. Cool. So this works. I need to rename all of these because this is deeply cursed. Yeah, let's... S1.x. I don't even really know what that is. This is the difference. Okay, so this is... Does it really matter? This is so cursed. You know what? It works. I'm okay with that. I'm okay with it being cursed. Damn, is it cursed? Okay. It should work at, like, no matter what the lines are. So now we just have to use this to check. It's kind of the hard part, maybe? Okay, so we're gonna re-enable our mesh test. Our mesh testing. And then this is the state that it's currently in. This one is the direction vector. Okay. I really should rename these, because this is just so unbelievably cursed. Line A direction, we're going to make this a vector 2. We're just going to set it to this. Okay, so this was the X. So we need to set all of these to X. And now we need to... Wait, what is the problem here? What is the problem here? We're just gonna act like I didn't actually rename it. Oopsies. Alright, so that's fine there. And then... This needs to be... For all purposes... Line A... Direction... I'm just gonna rename it to Line A Direction 1. And we're just going to do a little bit of this. We're gonna get rid of these. This is cursed programming techniques. Deeply cursed programming techniques.
Screw underscore it underscore, let's underscore do underscore it redeemed to say without hesitation. He flung open the hatch, just as his mother burst through his door, and threw himself down into the unknown depths below.
Brother! How much longer is the script? How much more do you have? I feel like that had to have been the end, right? Call them V0 and V0 as they are vectors? No. Okay. I will not call them V0 and V0. V0 and V1? No! No! Never! Why would I do that? Why would I do that to myself? I already have these horrible naming schemes. Why would I go to a worse naming scheme? Actually, that's probably better. At least I know it's vector. V1 Ultra Kill and V2 Ultra Kill. Name all the variables A, B, C, D. Okay. No. No, I don't think I will. Okay, and now we're going to have vector 2, line B direction. Okay, awesome. What is this variable? What do you guys think that we should name this variable? I'm thinking George, possibly Josh. This is gonna get a lot bigger though. Like the... Wait, was that an X? Yeah. Line B direction dot X. Right there. Right there. And then dot Y. Perfect. Josh is a solid name. Good, good, I'm glad. Okay. Okay. Dot Y. So now, if we go back, everything should still work the same. Wait. Everything should still work the same. This does look really cursed, though. It's fine. Everything should work, hopefully. Let's go in the mesh testing object again. And let's do... -3, 3, -3, 3... Okay, it still works. Nope, doesn't work. Okay, I messed something up. Okay. Okay. You're all gonna be mad at me? And... Oh no. Wait, that's what I messed up. Wait, no it's not. That's right. Yeah, no, that's right. Should be. Something's amiss. I think I'm... Okay, I'm not ever changing them. They are what they are. Alright. At some point, I'll actually figure out how the code works and then change them. But right now, not worth it. Okay. I'm trying to make this kind of work before I leave for 2 weeks. Okay, now it works. Cool with that. No collision. Awesome. There's a collision. I'll survive. This is deeply cursed. I hate this so much. Yeah, this is just wrong. Should I check the edge cases? Oh, oops. Yeah, it still works. There can be division by 0?
Boss Machine Amiga just followed.
Hey, Boss Machine Omega, thank you very much for the follow. What do you mean there can be division by 0? Oh, if any of these equals 0. So if there's no distance, wait. It's smart enough not to crash. Somehow. Oh, wait, no. Alright, wish me luck. Oh wait, actually, it is smart enough not to crash. That's kind of incredible. Okay. Because yeah, if it's on the same, then it should be... literally, this just equals 0. These will equal 0, and then it should divide by 0, and then die. But it doesn't do that. Somehow. It'll never equal 0. It's not possible with what we're doing. So it'll probably be fine. Is how I'm going to justify that. Okay, I'm gonna make a public void. Check lines. And then we're going to need a... Oh, why did my music stop? Okay. We're gonna take in a vector... 2 vector 2s. Vector 2, which is going to be... No, we need 4 vector 2s. Line A, point 1. These. Yoink. Mine now. We're just gonna call it A1. Vector 2, A2. Vector 2, B1. Vector 2, B2. And this is going to be a bool type, so it's going to return either true or false. And we're just going to do this. And we're going to return false. And then otherwise we're going to return true. We're going to change this to a1.x. No, this is a2. This is a1. These should be a1. Alright. a2. b1. These are cursed. It's fine. These are not good variable names. At some point, I'm gonna absolutely hate that I did this. But you know what? That's a future me problem, and I'm not currently future me, so I don't actually care that much. Future me's gonna be so mad though. Loser. Okay. And now I just have to A, B, A, B, sure, sure, wait, IntelliSense, are you smart enough to do this? No, you're not, that's okay. And now we're gonna check if this works by... We're gonna comment all of this code. Boop, boop. And boop, boop. And we're just gonna do check lines. Line A, point 2, line B, point 1, line B, point 2. Just blame the person you stole the code from. Okay. Based. I just might. Alright. If this, else. Alright, then we're going to print collision, else print no collision. We're gonna uncomment this bit. So we can at the very least see what the hell's happening. See if there is a collision or not. Okay, so we're gonna get into our base case. There's definitely a collision. Okay, awesome. And now let's set this variable like way over there, where there should no longer be a collision. Okay, there is no collision. There's no collision. There is a collision. Perfect. Very good. We might actually want to return a float, though. Which is the point. Actually, we should probably do a vector too. We're gonna return the collision point. Otherwise, or even what we could do is we could make this not return the vector 2, but instead, I guess, yeah, no, we can have it return the vector 2 or return null. Can I not return null? It's not a nullable type. It's a non-nullable type. Okay. Let's do vector 2. Problem. I don't think. What can I set it to? I could set it to like positive or negative infinity. But that really wouldn't work. So we're actually just going to set this to type bool, and then we're going to either return true or false, and then we're going to have a reference. Ref vector 2, and this is going to be the output, or the collision point. If it's true, then we're going to set the collision point to this. Otherwise, there's nothing to set it to. So, we're just going to set the collision point to nothing, I guess? We're just not going to change it. That'll be fine. Is it also handy to have the t value? Maybe. I don't know. I'll figure it out. We have the lines. Is there a way that I can make this... Okay, wait. Here's what we're gonna do. We're gonna actually put this at the end. So then I can do something a little fun. And have one without this. So that way we're not erroring anymore. This is the exact same thing as that. The t-value is just what percent along the first vector the collision is. That would probably be good to have. I don't know how it could hurt. This is what we'll do. We'll create a vector 2 here. Collision point. Equal vector 2 dot 0. And we're going to put in the collision point here. Ref. And then collision at plus collision point. There we go. So that we were actually testing as if it were a case. And cast it. against multiple lines, and it'll let you sort them by distance from the start of the first line. What? I'm not sure if I remotely understand what you're saying. Okay, awesome. So yeah, now we're getting the exact point that it was. And then we already have the velocity vector of where the thing's moving. Okay. Oof. I don't need anything in here, do I? No. Yeah, that's fine. I'm just gonna set it to vector 2.0 anyway, so that we don't ever have to define this. Oh no, you have to define in order to pass as a reference. Okay, that's fine then. Okay. Now here's the real scary part. Imagine one line needs to be tested against line 2, 3, 4. Okay. By casting against multiple lines, it'll let me sort by distance from the start of the first line. I don't think I need that in this case, because I either need to... T will let you know which one is hit first. Oh, that's true. That's actually completely true. I don't know how... I don't think that'll ever be something that I need right now, but yeah, you're right. That would be useful in quite a few contexts. And if I need it, then I will use it. Thank you. That's really smart, though. Yeah, okay. Okay. Whoop. Whoop. Alright. So we're gonna go to the mesh testing. And we're going to basically completely gut this. It's very fun, but like, I don't need it, so. Goodbye, code. All the times, I don't need these. All the times, delta times? Nope. I don't think we need spring force anymore, which means we don't need displacement, which means we don't need to check the last vertices. Which means we don't need last vertices. Alright, where's that error? Right here, perfect. We're gonna go back to where we were. When am I using this? Alright, sure. This should work. It should start moving again. Okay. Oopsies. Couple of things. That's way too big. Second of all, that's way too big. The spring force doesn't matter anymore, so... Okay. It's going to be like 3, so we have a little bit more fine control over what's happening. And we're going to set the damping a little bit higher. Okay, awesome. I just don't need spring force anymore, so we're actually just going to get rid of that. Now, every time we move a vertex, we update the vertice. Okay, this is silly. I shouldn't be doing this twice. So we're just going to instead int I. We're going to rename this to update vertex I. So that's fine. We can do some more, like, shorthanding, but not important right now. So every single vertex that we update, we need to check that it is not crossing the line. We only need to check it with the ones that are adjacent to it. Or not adjacent, sorry. The ones that are... Where is this? Okay. So if we have a grid, right? We have like 1, 2... I'm just gonna make a grid. So 1, 2, 3, 4, 5... 1, 2, 5, 6... 1, 2, 3, 4, 5, 6... 1, 2, 3, 4, 5, 6... Perfect. So, let's take this vertice. Let's build out all of the triangles around it. Okay. This one right here. We only need to check if it's crossing this line and this line, because it'll never go past those. And if it ever goes past those, like if it gets over here, then it crossed that line, so we don't need to check any other line. There's no point. Because if we have like one here, it will never cross this line without crossing this line. So we only need to check a line between what is directly to the right and what is directly down, and what is directly above and what is directly left. The far right one and the far left? What about them? I don't know if we need to check those. It can cross 4? Okay, how does this point ever cross any other line? Like, it can't cross here without crossing this. I suppose it could cross this. Do I just need to check every line? Oh no. Because yeah, it could cross this. The try on the right, it's on the opposite side. No. I don't think so, at least. Wait. Boop, 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 boop. What are you talking about? Okay. Whoop. There we go. Okay. Diagram made. So yeah, if we're like here, it'll never get past this vertex because this vertex is moving anyway. We don't have to worry about it crossing any of these, I don't think. Yeah, it'll never get past these vertices like its adjacent ones. Go right and slightly up. Right and slightly up. I am very confused. This line, yes. What about this line? Are you saying that it could cross this? Oh, I guess it could. Let's try to get it to cross one. Wait, so like right here, that would be like this crossing that, so it'd be like this crossing that. Oh, you're totally right. Okay. So we need to check this line. It can cross 6. Okay, so we need to check this line, this line, this line, this line, this line. Can't ever cross that one. It can cross this one, and it can cross this one. Wait. So yeah, so this one, this one, this one, this one, this one, and this one. So 1, 2, 3, 4, 5, 6. Yeah, you're right. Yeah, it doesn't need the internal line. Okay. So at, like, it's in a 4x4 grid, so let's just make another, like, small 4x4 grid. Or 2x2. So, like, this. And then I'm just going to label all of these. First I'm going to draw them, and then I'm going to label them. Okay, awesome. So this is our center vertex. And then this is 0, 1, 2, 3, 4 is our center. 5, 6, 7, 8. So we need to check between 3 and 7, 7 and 8, 8 and 5, 5 and 1, and 0 and 3. For every single vertex, we need to check these adjacent vertices. Which is just... it's the one directly above them. So it's up against left. So I'm just going to call that UL. So it's up against left. Up against top left. Or top right. So it's up against upright. We need to check upright against right. Gotta run? Yeah, thanks for stopping by, man. Have a good day. Okay, we need to do U times R, and then we need to do the right against the bottom, against down. We need to do down against down left. We need to do down left against left. I think that's all of them. Yeah. And I have a way to get the vertices by offset, which is nice. Very convenient. I just need to get whatever vertice we're doing, I just need to get all of the different indices and then pass them in to the line checker. I'm gonna make this private. This should equal A1, A2. Wait, what? Is this really right? Oh yeah, it is. Okay, there we go. And then I'm gonna make this private. There's no reason for this to be public, and I'm keeping everything in the mesh testing script, which is really messy, but I don't care. It doesn't matter too much. So we just need to check lines for cross. So we're going to rename this. Check lines for intersection. And we need to, every single time, I'm just going to create another function. This is going to be, well, no, we'll just do it in the update vertex. We need to get check lines. Oh, we have to do this for each of them. This is going to be kind of cursed, but that's okay. We're just going to do an if statement. We're going to do if check lines for intersection. We need to actually do this before we do this. Okay. This might be a problem, but I'm only going to add it if there's no intersection. Should be fine, hopefully. So we just need to check between the current. So we're going to get vertices I. Oh no. I just realized this is going to be a problem. Wait. Plus velocity. Or just multiply the velocity by the t value so it stops at the line. That's way smarter. Awesome. Return t, return 0. Okay. Not 0. We're gonna return -1. And we're just going to check all of the lines. We're going to set float t equal to check line for intersection. And it's going to be, we're going to do is times 2. Vertices I. Vertices I plus the difference, or plus velocity, sorry. And then we need to do get vertex by index offset. We need to, I'm just going to grab this, drag it over to my second screen. We need to do up and left, so that's going to be vector2 dot left. And okay. Vertices, this returns an index. Alright. The x difference is going to be -1 and 0. Why did I do it this way? There was a good reason that I had. But I don't have it anymore. Yeah, there's actually no reason not to just make this a vector 2. Oh, well, I didn't want to keep adding things to the heap. That's what it was. Yeah, whatever. I'll just keep it this way. Okay, and then vertices. This needs to be... So it's up left. Or it's up and then left. So we need to do up. I'm gonna mark on my sheet that I did that. And now we need to do the same thing every single time. We need to set t to all of these, and then if it's -1 still at the end, then we know that that is not the value. There's no problem. What is the problem? Okay. Yeah, I don't need the collision point anymore. We're just gonna get rid of that. We're gonna do this 6 times. Okay, this is going to be up and upright. That's gonna be 1, 1. Marking that off. I'm gonna add it back with the other one. This is going to be upright and right. So adding that, we're good there. And then I need right. It's kind of funny that that was actually correct. And then this needs to be 0, and this needs to be -1, because we're doing right and down. And now we need down and down left. And then for the last one, we need down left and left. So down left and left. I'm just gonna mark all of these. Down left, left. This is down down left. This is right, down. This is upright, right. And this is up, right, right. Wait, no, this is up, upright. And then this was up, left. Goodness gracious. The last one would be over right. Would it? Oh, yeah, wait. Okay, and this is gonna be float 0? Or this is gonna be 1, 2, 3, 4, 5. And it's going to be if... Alright, let's just do a for each loop. Let's do a for int I equals 0. I is less than 6. I plus plus. What is your problem? We're gonna call this J. I do not want speech recognition, thank you. Okay. If P J does not equal negative 1F, then times TJ, and then we can just return, not return, break from the loop. No need for an array. We just do T equals T, what? T equals T compared to 1? I have no idea what in the world that is. That's a lambda function, ain't it? No, that's like function short. What is that? For each line of the check lines calls. Okay. What you're doing is black sorcery to me. Alright? I have absolutely no idea what is happening. But I'm gonna trust you on it. We're gonna try that. T equals the function, wait, negative 1, the function T colon T what? Something's erroring. Okay, that fixes it. Okay. This should work. Set it to -1? Okay. Let's see. T is the first one, right? And to make sure S is the first one. Oops. Easy. Okay. Oops. Oh yeah. Okay. Um. I am gonna need an extra wide monitor. That's why I'm doing this, I suppose. What? Oh no. Wait, what? Oh, okay. Okay, this could be second index. We're gonna have int second index. And now I just have to set these every single time. This is just cursed. Because I need to check that this isn't breaking it. And I can only do that if it's -1. There has to be a better way of doing this. I quite frankly refuse to accept that there's not. Okay, wait. Hear me out. Vector 2 in. Offsets equals new vector 2 in. What is the problem? Do I have to do new vector 2 every single time? What? How do I do this? How do I make this nice? This doesn't seem to like when I do this. If I do vector... Oh wait, so it's x, comma y? Okay, whatever. I need 6 of these. And this needs to be offset 0. New vector 2 int. Yeah, I'm just gonna make an array that contains all the offsets and loops through them. Making it a constant wouldn't be a bad idea. Can you make it a constant? Const. Cannot be declared const. Alright. I should just do this at the start, though. Has to be initialized in line? Dude, I don't know how to do that. I don't think I can actually do that. No, you can't do const with vector 2. Nope. Well, shucks. Wait. Progress? My stupidity strikes again? New vector 2 int? Does this work? What is your problem? How to initialize vector 2 int unity. Brother, what am I missing? Wait, vector 2 int array. I don't want to deal with tuples. We already have vector 2s. What? Okay. Wait. Why is this a problem? Oh, you can't do it that way. You just can't initialize it. So it can't be done this way. It's fine. It doesn't matter. I'm done playing with it. New vector 2 int. -1, 0. I'm just gonna do all of them. Like this. And then this was 0, 1. Two. This is 1, 1. And then it's 1, 0. Okay. Then now I'm gonna have to keep track of which ones are which. This is turning into a lot more of a hassle than I thought it would be. Wait, I can just do it this way. Okay. Awesome. Doing the first index and the second index, that's going to get real complicated, but we'll just ignore that for a second. We have all of the offsets. Wait, no we don't. We will in a moment. Why? I don't know anymore, okay? I don't have reasons. Because it'll be easier, I think. Let me cook, alright? Allow me this moment to cook. And then you can get angry. Okay, because these are the 6 offsets we need. There's overlap. Okay. We need up. Up. And then we need up left. Or up right. So it's 1, 1. And then we need right, which is 1, 0. And then we need down, which is 0, -1. And then we need bottom left, which is -1, -1. And then we need left, which is -1, 0. And that's all we need. We need just those. We only need 1, 2, 3, 4, 5, 6, 7. What? 1, 2, 3, 4, 5, 6. 6 points. What am I missing? Okay, we have up, right, right. We don't have just right. No, we do have just right. We have up, right, right, down, down left, and then left. Okay, there we go. Now we're going clockwise. And with this, because we're storing all these index, and then we just need to use them here. So... I'm going to get rid of all of these. And then we're going to figure out how we're doing this. Okay. So it's not first index, second index. These no longer exist. Alright, so now we need up and left, which is offsets 0 and offsets 5. And now offsets, we need up, so that's offset 0, and then we need upright, which is offsets 1. And then we need upright, which is 1, and then we need right, which is 2. And then we need right, which is 2. And then we need down, which is 0, 1, 2. What the hell? Do I not have a down? It's a disaster. This is supposed to be down. So it's offsets 3. And then we need down again, which is 3. And then we need down left, which is 4. And then we need presumably 4 and 5, given the pattern. Which I think is true. Yes, 4 and 5. Down, left, and left. Which is 4 and 5. The code is almost readable. Yeah, I can just do index. You're right. int I, nope, int j equals 0. J is less than 6. And j plus plus. We're going to do, this is going to be j, and j plus 1, but not actually. Because yeah, it would be j plus 1 modulo 6. No. It's j plus 1 for all of them except the first one. So if I just... Bam. Coding. Okay. There we go. So now it'll be 1 and 2, and then 2 and 3. Index plus 1, the modulo 6? Okay, but when j is 5, it'll just be 5. When j is 0, then it'll be 1. We need this. I'm pretty sure. No, actually that would work. Because at the end they would do, j plus 1 should be 6. Modulo, yeah, you're right. Alright, modulo 6. Alright. Let's see if this works. Nice. Oh, Unity's crashing. Nice. I don't even know why Unity's crashing. What the hell's that? If t does not equal -1, then break. Okay. Yes. This isn't infinitely looping or anything, no. Why did it just die? What happened? No, 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 you're good. Whoops. Wait, what? Oh. Okay. I need to check if j, or if j is not equal -1, and j plus 1 mod 6 mod 6 does not equal -1. I'm gonna do int first. index, and that's just going to equal j. Int second index, and that's just going to equal this. We're not going to do that, but we will do second index, just so I can use this easier. Okay. Then we want to do this. Yes, offsets. Thank you. Okay. Goodness gracious. Okay, now it shouldn't error. Please? Please don't error? Um... Oh. Uh... Yeah. Else? Or is it, if it equals -1, then don't do anything, otherwise... Yeah. We want to multiply it by s, otherwise we just want to do vertices I plus equals velocity. Okay, that should work. Nope. Damn it, man. Okay. Okay, we're gonna do intersection at... What was the... This? S. And then we're gonna do... A1. A2. A1. Perfect. Thinking it's landing on it, stopping, then the next it goes through? Maybe? It's calculating that there... No, wait. It... It knows there's an intersection. What's the problem? If I return T, does it work? Yes. That's kind of funny. Nope. I'm just an idiot. I'm renaming this to velocity mode for my own sake. Well, now this line is long. Ugh. Whatever, man. It's already cursed. I don't care. It doesn't need the teenery now? Okay. That's fair, actually. I'm getting real creative with my variable names. This returns a float, and then I need to do if this equals if this ever... No, wait, I can just set it every time. Yeah. This should work. Yeah, I can just set it. Okay. Alright. It stops it from breaking. Okay? Like, it looks like trash. But if we set the, if we set this material here to the white texture, oh my goodness, instantly, how did that break? Anyways. Alright, where are the UVs? Where does it say UV per side? Yeah, okay. Here's what we're gonna do. We're gonna be like, hey, okay, UV index. You're just gonna, like, be 0, okay? Are you happy with that? Can you be okay with that? Please? We're gonna do vector 3.0. Actually, it's vector 2.0. Alright? We're just gonna pretend like that's not a problem. I'm just gonna ignore the problem. Because it's not one. What problem? I kind of can't believe that this actually works. Holy shit. Easy. Not even close. So easy. Only took like a week and also someone who's much better at programming than me to walk me through like a child. But it works. Thank you very much, Whale Time. Thank you very much. This would have taken me a lot longer if you weren't here. Like, actually. Oh, man. Dude, I can't believe that works. I'm so happy. I've been trying to figure out this problem for like a week. It's over. It's done. Okay. With that, I'm gonna end stream. I will be back. It's gonna be 2 weeks. It's gonna be a bit. I'm going on vacation. I'm going to see some family. I will be back on the 19th. Tuesday the 19th. If you'd like to keep updated, you can go to the Discord server right here. I'd love to have you. I'd love for everyone to show off your work. Yeah, thank you. You honestly think re-implementing the spring stuff would make it move nicer? Okay, wait, maybe before I go. Okay, wait, before I go, we're gonna try that. One last time. Yeah, I'm gone until the 19th. I'm going on vacation. I'm going to Florida. Okay, you know, I'll deal with the spring stuff later, actually. I'm very tired. It's good to see you, Thorn, today. I hope everything's going good for you. Have a fantastic night. Yeah, Florida in March. If you want to keep talking, you can DM me. You have my Discord. Okay, I gotta get up, though. You guys are awesome. Love you all. Thank you very much. Have a good day. Have a good